Welcome viewers. Right. Now our course on metal cutting and machine tools. Right. Now this lecture will be attained in some different aspects like our what is metal cutting and what is machine tools, right? And what are the different aspects of cutting, right? So in this process, the various functional problems are occurred in the rough overview. I would like to give a rough overview on what is cutting and what is a tool and what is a cutting force, what is the required angles, right? So now the basic fundamental processes are in this metal cutting and machine tools, the classification of metal removal process and machines. Okay, what is metal removal process and machines? Okay, right? So the concept of Generatrix and Directrix of geometry of a single point cutting tool and tool angles, right? And tool nomenclature, right? The basic need of the metal cutting and machine tools, we need to know the overall nomenclature, right? Tool nomenclature in ASA, right? And ORS and NRS, and interrelationship between all these three things. Okay, the concept of orthogonal and oblique cutting mechanism of formation, chip formation, right? In this chip formation, type of chips. Okay, basically we know that what's going on in machining. Simply we are giving a working tool, right, with a feed, some instantaneous axis of rotation. So in that, the chip formation is simply removing a material from the main workpiece, so that mechanics of metal cutting and interrelationships between the cutting force, shear angle, strain and strain rate. Okay, various theories of metal cutting, thermal aspects of machining, and the measurement of chip tool interface, temperature, friction in metal cutting, right? So these other things are completely related to mechanism of chip formation. Okay, so the basic chip formation needs the angles, strain rates and stress rates between the interrelationship between the cutting force and shear angles, so that the fundamental way we need to learn these things, right? Friction in metal cutting and introduction to tool geometry, milling cutters and drilling cutters. Okay, so that the basic needs are to create the maximum maximum speeds at the drilling forces and shift forces. Okay, right. Right, metal removal process. Basically what we know that a simple metal removal process, a family of shaping operations, the common feature of which is removal of material from a starting work part, so the remaining part has the desired geometry, the machines on which these operations are performed called machine tools. we know that the value of the value addition by machining, it is a valuable addition process by which raw materials of low utility and value due to its inadequate materials, right? Properties and poor or irregular shape and finish are converted into high utility and valued products with definite dimensions, forms, and finish, imparting some functional abilities, right? So generally we are going to machining what is the input and what is the output. So between the processes, we need to understand what is the main process. So initially input is common, output is common, whatever it is, the process is going on. But when the process is occurred, what is the feed rate, speed rate, and what is the particular operation they will be conducted, right? And the second one is variables in process of metal cutting. Okay, what are the variables we are observed in metal cutting processes? So that the one is machine tool selected to perform the process, right? So which is the machine tool selected to perform the process. And the next one is cutting tool. So that cutting tool means what is the object to remove the material from the main workpiece. So that the tool has also having geometry and material. Okay, what is the material to use to remove the material in the formation of chip. Okay, next one is properties and parameters of workpiece, and next one is cutting parameters. Like what are the cutting parameters? I think you know people already well in your previous sessions, I mean previous semesters: speed, feed, depth of cut, right? These are the cutting parameters. Okay, the next one is working holding devices, workpiece holding devices. Okay, so those are jigs and fixtures. We know in previous sessions, I mean previous classes, like our MT machine tools and our lathe machines. Generally, we are observing in our colleges jigs and fixtures. So these are the fundamental needs to know what is the funda of our metal cutting, right? So the inputs and outputs. So what are the inputs to machining? So input is, first one is machine tool selection, right? So the machine tool selection, the first one is lathe, milling machine, drill press, grinder, saw, broach, machining center. These are the inputs for machine tool selections, right? So the next one, workpiece parameters. Coming to the workpiece parameters, we know pre-deformation work. Deformation is nothing but structures observed in the material. I mean FCC, BCC, HCP. Okay, like ferrous materials. Next, SFE and purity. Okay, next one, cutting tool parameters. Okay, coming to the cutting tool parameters, we know that tool design geometry, right? That contains tool angles, nose radius, edge radius, material, hardness, finish, and coating, right? So next, cutting parameters: depth of cut, speed, feed, environment means what is the ambience circumference of the material, like oxygen, lubricant, temperature. Okay, the work holders are fixtures, jigs, chucks, and collects. Okay, these are the basic needs. Okay, needs to give the machining processes, right? So coming to the outputs processes, measurements, cutting forces, cutting force measurement, chip dimension. What is the material to coming out from a workpiece? That is also having some dimension like optical, SEM. One set of shear direction, power, surface finish, tool wear, failures, deflections like temperatures, vibrations, and part size. So these are the outputs. After the process coming, those are the outputs. So next one, finally we got the determination having the project. I mean having the output. So that's one is specific horsepower, HP. Next one, flow stress, chip ratios, shear front directions, velocities. I mean with that velocity having also chip, shear, the remaining etc. parts, friction coefficients, strains, cutting stiffness, heat, and tool inputs. So these are all completely related to input and outputs of a simple machining, right? So the machining is also having on different classification that are traditional process. Okay, that simply says a simple traditional process is having material removed by a sharp cutting tool. Okay, machining, generally we know what is machining: a material removed by a sharp cutting tool. For example, turning, milling, and drilling, the other machine operation. So the other machine operations means like conventional machining, abrasive process, non-traditional machining, right? So what is abrasive process? A material removal by hard abrasive particles, right? The abrasive is nothing but a jet process. Okay, I'm not talking about aeronautics. In this, a jet force, a particle is acting on a workpiece to remove the chip or to remove the material. Okay, that is nothing but honing, lapping, and super finishing, right? And non-traditional process, coming to the non-traditional process, various energy forms other than sharp cutting tool or abrasive materials to remove material generally by erosion. Okay. For example, laser and electron beam machining. Right? Erosion is nothing but laser and electron beam machining. The energy forms include mechanical, electrochemical, thermal, and chemical. Right? So, coming to the conventional machining is nothing but turning and related operations, drilling and related operations, milling, and other machining operations. Right? Abrasive machining is nothing but grinding operation and abrasive processes. Coming to the non-traditional processes, mechanical energy process, electrochemical machining, thermal energy process, and chemical energy process. So these are all metal removal processes. Okay, so generally we know finally we got advantage and disadvantage of material removal processes. The advantage of machining is variety of work materials can be machined, variety of parts, part shapes, and specific geometric features possible, good good dimensional accuracy, and good surface finish. These are the advantages of machining, right? So the based on characteristics, we can define the disadvantages also. Chips generated in machining are wasted material. Oh, that means wastage is nothing but we have to achieve a different shape and different size of the material, and time consuming process, of course. The bulk production and bulk manufacturing process are having some different time consumptions also, right? Furtherly, we need to know the basic principle of machining, right? Just listen carefully. What is the principle of machining? First, initially, we have to understand it. So, machining is a manufacturing process in which a sharp cutting tool, right? Guys, listen carefully. Once again, I would like to repeat it. Machining is a manufacturing process in which a sharp cutting tool is used to cut away material to leave the desired part and shape. Right? Desired is nothing but it is predetermined. Okay, so predetermined value and predetermined shape we have to achieve it. Right? The predominant cutting action in machining involves shear deformation of the work material to form a chip. Right? As the chip is removed, a new surface is exposed. Machining is most frequently applied to shape metals. Right? So these are the basic principles of machining. Right? Right. Now the discussion on machining operations. Okay. So the machining operations are different. You know that what is turning, drilling, milling, shaping, planing, broaching, and sawing. So that turning, coming to the turning point. So what is turning? A single point cutting tool, right? A single point cutting tool removes material and rotating, and a single point cutting tool removes material from a rotating workpiece to form a cylindrical shape. Okay. So in this aspect, the cutting tool is fixed. Okay. Here in the figure is observe here. The cutting tool is fixed. The cutting, the material removes towards the rotating workpiece from cylindrical shape. Means the turning, most of the turning operations to form a cylindrical shape. Okay. Next one is the drilling. The drilling operation is used to create a round hole. We need to drill inside the to form a hollow shape. Okay, so the drilling operation is used to create a round hole by means of a rotating tool. The tool is nothing but our drill bit with the two cutting edges, right? So in this, the diagram is shown like this. The drill bit is having two cutting edges, right? The next one is milling. It means rotating multiple cutting edge. Okay, it is having initially a big solid edge tool. It's a sharpened solid edge tools is removed to across work to cut a plane or a straight surface. Okay, so milling is nothing but it is continuously the number of straight cutting edges are continuously removing the material from the workpiece. So it is used to form a straight surface, right? Next one is shaping and planing. Shaping is also like to remove the material from the workpiece to form a flat surface, right? Next one, broaching. In this broaching, we are observing that the multi-teeth tool is placed in a single stroke. Okay, a multi-tool is placed in a single stroke. The multi-teeth tool used to make roughing and finishing in a single stroke. Roughing and finishing a single stroke. Next, sawing is nothing but in this sawing, the cutoff operations are continuously acting like our milling. Okay, these sawing and milling are generally we are observing in our carpentry shops and other different applications. So these turning, drilling, milling, shaping, and broaching, sawing are the very introduced operations, very basic introduced operation in machining operations, right? So in this aspect, we need to know what is the generating point and what is the working areas. Means initials and next level operations. That means the machine tools generally provide two kinds of relative motions, right? The first one is primary motion and secondary motion. Now coming to the primary motion, it is the relative motion between the tool and the work responsible for cutting action and absorbs most of the power required to perform the machining action, right? In this sentence, we are observing the relative motion between the tool and work responsible for the cutting action, and this absorbs most of the power required to perform the machining action. So primary action is nothing but which is used to remove the which is used to remove the material from the workpiece. It needs some power, that says in this sentence, and absorbs most of the power required to perform the machining action. So this is the initial step towards the machining. So that is nothing but primary motion. And the second one is secondary motion. It is responsible for gradually feeding the uncut portion and may proceed in steps or continuously and absorbs only fraction of the total power required for machining. Depending upon the nature to relative motion, various types of surfaces can be produced. That is nothing but the secondary motion is nothing but after starting the machine or a process, we need to continue means to lead the next step to next step. In this aspect, we need to correlate the primary action and the secondary action. So the may proceed the steps or continuously absorb the fraction of the total power required the machine. So it means to attain the desired shape, we need to continue the process. Initially, we need to continue the process towards the attaining shape or predetermined shape. Next one is Generatrix. What is Generatrix? The line generated by primary motion or cutting motion is called Generatrix. It is very important sentence and important definitions also remind it. So we need generally we have a plan to take an action towards the shape or towards the dimension. So that is called Generatrix. The basic lines, the line generated by primary motion or cutting motion is called Generatrix. Directrix is nothing but the line representing the secondary motion, means feed motion, is called Directrix. It provides the path to Generatrix. Okay, so the Generatrix and the Directrix are the very correlated or interrelated axes. It's very important lines. The Generatrix is nothing but cutting motion, Directrix is nothing but feed motion. So depending upon the shapes of the Generatrix and the Directrix and their relative orientation, various geometries can be produced on the workpiece. Okay, so that is nothing but concept of Generatrix and Directrix. For example, in our regular observation, the cutting motion to produce a general flat surface, the cutting motions as well as the feed motion are rectilinear but perpendicular to each other. Okay, The cutting motions as well as the feed motion are rectilinear but perpendicular to each other. Here the machined surface produced is a plane. Observe the diagrams in generation of flat surface by Generatrix and Directrix. Okay, the first one is observe the figure D and G. This is the Generatrix and this is the Directrix. Okay, so these are the rectilinear, but that means straight lines. But these are the perpendicular each other. Here we have the 90 degrees perpendicular angle here. Right. The principle shown the diagram where the flat plane's straight line is called G is transferred to perpendicular direction. That we are discussing earlier. This results a flat surface. Okay. Next, generation of cylindrical surfaces. In this, the principles of production of various cylindrical surfaces. Cylindrical surfaces is nothing but in our earlier discussion, we are already discussing about turning and drilling. Right? The principles of production various cylindrical surfaces. Coming to the diagram, a long straight cylindrical surface obtained a circle. Okay, obtained a circle. It is transverse to the direction D parallel to the axis. Okay, so as like as same flat surfaces, so the following are generation of cylindrical surfaces are same principles, right? So the now coming to the working motions. The working motion is nothing but where we are the main working motion is tool working motion. The lines representing the Generatrix and Directrix are usually produced by the locus of a point moving in two different directions and are actually obtained by the motions of the tool tip. Right? It is related to the work surface. Hence, for machining or machining flat or curved surfaces, the machine tools need relative to work motions. So that formative work motions are cutting motion and feed motion. In our earlier discussion, we are discussing already cutting rate or feed rate. So same as cutting motion and feed motion. The cutting motion is nothing but primary motion. The feed motion is nothing but secondary motion. Right? So these are the fundamental diagrams, means longitudinal turning, transverse turning. Right? In the first longitudinal diagram, we can observe cutting motion means in rotating. So here the tool is in direction of feed motion. So this is the Directrix and this is the Generatrix. Coming to the transverse turning, this is the feed motion and this is the cutting motion. This is the Directrix and this is the Generatrix. Right? So here observing the diagram, principles of producing flat surface in shaping machine. So this is the cutting motion, here the feed motion. Desired flat surfaces are occurred here. So these are the interconnections between the auxiliary motion, means indexing motion, additional feed motion, relieving motion. Right? These topics are discussed in concept of Generatrix and the Directrix. So in this case, where we have to discussing about tracing TR, right? So the Generatrix and Directrix can be obtained in 4 ways, right? The first one is tracing, second one is forming, third one is tangent tracing, and fourth one is generation, right? So coming to the tracing, where the continuous line is attained as a trace of path of a moving point, is nothing but tracing, right? So the tracing operation observed here. So the diagrams are indicating feed motion and cutting motion, right? Next, forming F, where the generatrix is simply the profile of cutting edge, that is forming. Here the forming is nothing but where the chip is removed from the material at primary motion, that is nothing but forming. And tangent tracing, where the directrix is taken as the tangent to the series of paths traced by the cutting edge, right? Here the work is contained cutting motion and feed motion. The work of the tool to remove the material in the form of chip, where the cutting edges are indicated, that G and D are connected here with the tool work motions G, X, T, F. So directrix formed by tangent tracing in plane milling. So this is the tangent tracing. Next, coming to the generation. Here G is nothing but generation, is obtained as an envelope being tangent to the instantaneous positions of a linear or surface which is rolling on another surface. Gear teeth generation by hobbing or gear shaping is the example, as can be seen in the diagram. Generatrix or directrix in gear teeth cutting by generation, right? Coming to the point, concept of rack and clearance angles of cutting tools, right? The rack and clearance angles of cutting tools. The word tool geometry is basically, the tool geometry is basically referred to some specific angles or slope of the salient faces and edges of the cutting tools at their cutting point. Rack angle and clearance angles are the most significant for all the cutting tools, right? The referred figures are here. This is the clearance angle, and VC is nothing but cutting velocity. The phi r is nothing but a reference plane. This is the rack angle, the angle between the workpiece at a perpendicular line. The angle between the cutting tool is called rack angle. The rack and clearance angles of cutting tools here. So this is the nomenclature regards the machine tools and cutting angles. Definition. Definition of a rack angle: the angle of inclination of rack surface from reference plane. Next on clearance angle, Y, angle of inclination of clearance or flank surface from the finished surface. Right. Next, positive rack. A tool has a positive rack when the face of the tools slopes away from the cutting edges and slants towards the back or side of the tool. In most cases, tools are provided with a positive rack, right? Here we have to observe chip force on the tool. Okay, when the sharp cutting blunt knives are generally used in helps reduce cutting force requirement and thus cutting power requirement, right? The force acting on tool tends to break tool tip or shear off the cutting edge of the tool. In the most cases, tools are provided with a positive rack. Positive rack angle makes the tool sharp and pointed, but reduce the strength of cutting edge is very essential. The sharp pencil tip breaks. It helps the formation of continuous chip in ductile material and contributes to avoiding the formation of built up edge chip. And the recommended points are here: low strength, soft ferrous and non-ferrous metals, low power machines, long shaft of small diameters, setup lacks strength, low cutting speeds, and cutting tool materials as HSS. Next one, positive rack. Next one, negative rack. First we are discussing about positive rack, and second one is negative rack. The negative rack, as a tool has a negative rack when the force of the tool slopes away from cutting edges and slants upwards the back or side of the tool. In this, to increase the edge strength mechanically and thermally, life of the tool, more area helps in heat dissipation as well as provide strength. The cutting tool with the negative rack angle is stronger, nothing but blunt, stronger is nothing but blunt rack angle, can take heavier depth of cut and use it to cut high strength material. Negative rack angles prevents adhesion, increase the surface finish, increases tool wear and increases the tool life. Higher, and it having higher cutting force during machining, this also increases the power of consumption and increase vibration, friction and temperature at a cutting edge. And it is recommended for machining high strength alloy, high cutting speed, high speed cutting with rigid setup to resist vibrations. Cutting tools are ceramic and carbide. Tools are subjected to compressive forces. And next one is zero rack. Zero rack is nothing but design manufacturing of the form tools. In generally, a neutral rack angle tool is simplest and easiest to manufacture, but it causes a massive crater wear when compared to other types. The neutral rack angle obstructs the movement of the chip flow and causes built-up chip formation. Examples: gear cutting in milling machine, thread cutting in lathe machine. In these two machinery processes, we are observing the zero rack, means manufacturing materials. Next one is clearance angle. The angle is essentially provided to avoid rubbing of the tool with the machined surface, which causes loss of energy and damages of both the tool and job surface. Hence, the clearance angle is must be positive 3 degrees to 15 degrees, depending upon tool work materials and the type of the machining operations like turning, drilling, boring, etc. Next one, cutting parameters. We know that cutting speed, feed, and the depth of cut, right? And these are the according cutting edges, single point and multi points, double points, according to motions, linear motion tools, rotatory motion tools, linear and rotatory motion tools. Those are the examples for this. And